Hi everyone, our today's session is about gradient or slope. They're the same thing. They're named differently when people talk about it. Now, for gradient and slope inside the linear equation, we have learned about that in year 9. But most of us just learn how to read the gradient from a standard form of linear equation. For example, we have y equals to mx plus c, then we know that the m over here is gradient. And then we might also learn how to calculate gradient from some given points also. So today's session is more like a revision about what's the meaning of the gradient and how do we find it. Okay, so now if we look at the picture that's on the left, we have three linear lines, line A, line B, and line C. They if we look at what they have in different, I think most of us will be able to identify the steepness, the angle from the line to the horizontal line over here, they are different. Okay, so the incline is different. But the incline is called the gradient, and we can see that it actually forms a slope, so it's also called slope sometimes. Now for most of the time, I will use the word gradient because I think that is how it is referred in in the further maths examinations, and this is also a less familiar word for all of us. Okay, so if you look at A, B, and C, we can say that the incline is different. Now, for every single graph, we need to relate that to the number. We need to relate all of them to mass. So how does the gradient or how does the incline actually relate to our number? If we look at if I take 2 points from the graph, okay, the first point is going to be 0 on the x-axis. So I find 0 on my x-axis over here, and I go up. Then what I realize is all these three lines, they're all starting from the same point at this instant. So when x is 0, all their y's are equals to 2. Now the other one that I'm going to take is I'm going to find when x equals to 1, what does the point equals to on different linear equation. So on A, when x equals to 1, the y coordinate is 7. Okay, so I go 1 up. Okay, so I find this point over here, and then I read it from the y coordinate is in between 6 and 8, so that's going to be 7. So the coordinate of that is going to be 1, 7. And for my line B, I'm going to use the same method. Let me find a colored pencil. Okay, so in line B, when I go up over here, go up from the 1, I can see that my line is somewhere in between the 3 and the 4. So let's call it 3.5. So when x equals 1, y is equal to 3.5. Now if we move to our line C, the blue line over there, we're still looking at when x equals 1, what does the y equals to? So when x equals to 1, the y is somewhere about 2, somewhere in the middle of 2 and 3, so let's call it 2.5. Okay. So they all starting with 0, but they are traveling they have traveled different distance along the y coordinate. So when in between, if we take x, the horizontal coordinate as time travel, y as distance that they have traveled, then we can see that the person with a speed of a, or the person A, in the 1 hour or 1 minute or whatever, they have traveled furthest compared to the person B or the person C. So gradient and slope is really about how fast that your y is changing based on given unit of x. Okay, so I will write this down on the screen. Now make sure that you copy this in your book, because lots of the question in the further maths examination or in the general maths examination, they will ask you what is the meaning of the gradient. So I will write down the general definition for it, and then we will see later on we will see some example, and we will put that into the language that's using the same language as the question asked. Okay, so let's just write down the definition now. Okay, the information I wrote over here is gradient is the change in y in unit change of x. Now I have write down my y and x in red because sometimes we don't have these two letters represent our responsive variable and explanatory variable. Responsive variable is our y categories. I'll write down RV and then x is our explanatory variable. So that's going to be my EV. And we also learn responsive variable as dependent variable in year 9 and explanatory variable as independent variable in science and year 9 math class as well. So they both are interchangeable. Okay, so gradient is the amount of change in y, or we can say the change in y in unit change of x. What does unit change means over here? So if, for example, if my time, the unit of my time is in second, then it's in 1 second with an x change in 1 second change of x, and if it's in hour, then it's in 1 second change of x as well. Okay, so the unit is what's the unit of your explanatory variable. So this is more of a general term. Now we will give it some numbers later in our topic, and then we'll put that into use. But please make sure that you write down the definition of gradient over here. Now I have got rid of all the writings over there. Now could you give it a guess which of the line A, B, or C have the largest gradient or have the largest change in y when x changed by 1 unit? Okay, so the answer will be A. So if when x is changed by 1, so from 0 to 1, A has the greatest change compared to all the other lines. So if the angle in between the line and the horizontal axis over there are larger, then the gradient is also going to be larger as well. And all the gradients for line A, line B, and line C are all going to be positive. Because with the increase of x, we can see that y is also increasing. It doesn't matter it's increasing really fast or increasing really slow. They're all increasing. Now, how do we know that if a gradient is increasing or decreasing? The way to look at it is we're going to look at the x coordinate. So we're going to look at the graph from left to the right. Okay, so we're going from left to the right in this direction. And if you look at the right line, when we go from the left, that's the left hand side, most left hand side of the line, and that is the most right hand side of the line. So we are looking at it this way. Now, when we're looking at from left to right, and the line is going up, so now we can see the line is traveling up. That means that it's going to be a positive gradient because our y is increasing when going up on the Cartesian coordinate. The vertical axis rating is increasing, so our y is increasing when x increases. The relationship in between the change of x and the change of y is going to be a positive relationship. So that is why our gradient is going to be positive. Now, if we look at it from right to left hand side, so we're going through the other direction, our x is decreasing and our y is also decreasing. So means that we have a positive relationship, but in that way it's a bit confused because it's going down over here, but our gradient is still positive because gradient is actually representing the relationship, whether it's proportional or proportional or inversely proportional to the other variable. Okay, so for future reference, when I talk about the line is going up or going down, we're all talking about that when we're looking at the graph from left to the right. So we're all looking across the graph over there, whether the line is traveling up or traveling down. So all these three lines, they are traveling up over there. Now below I've got some examples for the lines that are traveling down. The line B, E, and F. So if you look at it from left to the right, the lines are all traveling downwards. Okay, so the gradient is going to be negative for them all. Alright, the last Cartesian coordinate plane I'm going to show you is G, H, and I. So the relationship between the linear line G, H, and I is that they are all parallel to each other. So when they are all parallel to each other, means that the incline or the angle between the line to the ground level or to the horizontal level are all the same. So we learned that gradient is about the change, is about the angle. So when they are all the same, we call them that they have the same gradient. So the gradient for the line G, for the line H, and for the line I, they're all the same. Then we know that because all these lines are parallel. So let's write down parallel means that it needs equal gradient. Okay, so parallel line indicate equal gradient. And then you can also write down when the line is going up, positive gradient. And when the line is traveling down, we can write it as negative. So you can write the abbreviation negative sign followed by VE, negative gradient. Okay, next section we're going to move on to calculate the gradient. In the previous part, we talked about the gradient is about the angle in between the horizontal line and the linear line itself. But if we're talking about angle, there is something that we all hate, okay, or most of the students hate. It's called trigonometry, and gradient is related to that. So if I look at this angle over here, I'm going to label that, I've changed the color. I'm going to label that as alpha. And I'm going to label my angle as, let's label it as O because it's opposite this line. Okay, I'll write the number, write the letter over here. So that's my point A, point B, and point C. This line, I'm going to label it as A, and this line I'm going to label it as H. So opposite, adjacent, and hypotenuse. So if I label that over here first, and then you're going to see what I'm going to use that for later. Okay, so alongside with my rise, with my A and O, you can also see that some people write run and rise over there. Run is going across the horizontal distance from the point that was chosen or from the pivot to the point B. Okay, so the horizontal distance in between point A and point B. That's called a run because that's running across the Cartesian coordinate plane. So if it's going in the horizontal direction, it's called run. And if it's going to the vertical direction, it's called rise. That's the vertical difference or vertical distance in between my point A and point B. How many units has point then rise to go to point B. Okay, that's why we have the word runs and rise. And to calculate the slope, now also remember our slope is our gradient. So to calculate the gradient, we use the formula rise or run. So the distance or the units that you have to rise over the unit that you have to run. Now let's look at back to our triangle and then to a right angle triangle. Our rise can also be represented as O opposite, and a run can be represented as adjacent A. So O or A in trigonometry we have tan theta or tan alpha in our case, in my case, is equal to opposite or adjacent. So in some of the questions, the gradient is also called the tangent, but that's not with linear line. It's more with a curved line, but it's all talking about the change of that point. Okay, so the change of y for 1 unit of x or for unit measure of x. Alright, so okay, now that's about the triangle that we draw now. So let's put our triangle back to the linear line or to the Cartesian coordinate. Okay, the first question, find the gradient of the line passing through the point -2, 5, and 1, 14. Okay, so first, it doesn't look like what we have been teaching. Now what I'm going to do is I'm going to fit these 2 points in the Cartesian coordinate, And from the previous question, we find out we have to allocate a triangle, and we need to find out what is the rise, what is the run, in order to calculate the gradient or the slope. Okay, so let's find our point first. Now, my first point is -2 and 5. So when x-axis is equal to -2, y equals to +5. So that's my first point. -2, 5. Now my next point is when x equals to 1 and y equals to 14. So it's about over there. So 1, 14. And now I've joined these 2 points with a linear line over there. Now in that linear line, could you find a right angle triangle that uses the linear line as its hypothesis? Okay, so I will give you a hint. And because we're going to find out what is the rise and what is the run, so we're going to find out the horizontal and the vertical distance between the 2 points. So I will travel from my first point and then I will go to its right because it's on the other point is on the right hand side, or my point A and my point B. That's the horizontal difference in between my point A and point B. Okay, the next one we're going to see what is the vertical distance in between my point A and point B. Okay, the vertical difference is that. Now if you look at the run, so from -2 to 1, it has to go for 3 units to the right, and from the 5 to the 14, it has to go up for 9 units up. So 9 units upwards, and this is going to be 3 units to the left. And in our equation, we say that our gradient is equals to run over rise. Oh, sorry, it's going to be, our equation is going to be y rise over run. Okay, rise over run. So it's going to be 9 over 3. So the answer for this question is going to be 3. Okay, so in our Cartesian coordinate plan, we have located this triangle, and then we find out what is the rise and what is the run, put that into the formula and calculate that. Now, some of you might notice when we do this calculation, I was talking about how many units from A to B, how many, but in all our questions, there's actually a direction where A is traveling to the right to get to B, and A is also traveling up to get to B. The to the right and to and upwards, they are all positive. They are all improving in the one is improving in X and one is increasing in Y. So they're all increasing order. Now, if we have a different cases, we are not going to look at a positive numbers over there. So the direction is actually very important when we calculate the coordinates. Okay, there is also another formula when we use different points to do it. Okay, now I will going to get rid of that, and now I'm going to use a different method. So to calculate that the rise, I find out the difference in between that. But the best way to find out it is I need to see how many units is traveling upwards. Now, how many units is traveling upwards? Or B is 14, and then the vertical coordinate for my point B is 14, and the vertical coordinate for my point A is 5. So it has traveled 9 hours. So to get the 9 units upward, we actually use 14 minus 5 to get that. And for the run, we actually use 1 take away -2 to get there. Okay, so if you use -2 take away 1, you will have a different answer. Now, we only want to know how many units is traveling up and how many units is traveling to the right. Okay, so if we have a positive number, means that it's traveling these many units up. But if we have a negative number, so it means that it traveled these many units downwards. The negative units indicate a different direction. Okay, so this question will have 1 take away 2, which is equal to 3. So this is what we are actually calculating when we do these questions. There's always going to be beneficial for us if we have a generalized formula. So the generalized formula for gradient or to calculate our slope is change of y coordinate over the change of x coordinate. Okay. Now the triangle, also named as delta, represent the change. We've learned that in science, and then I think I've showed that a couple of times in math as well. Okay, so change in y coordinate, we use second point take away the first point, the y coordinate of the second point. Now in our case, we use b as our point 2, so we use 14 take away 5, that's y2 take away y1. And for the horizontal coordinate, we're using the same thing. We use the horizontal coordinate of b, so we use 1 over here, take away the horizontal coordinate of my point A, take away -2. So it's going to be x2 minus x1. Okay, so this is the general formula if we are given two coordinates that's on the graph. Okay, now let's look at another example. So we are also going to find out the gradient of this linear line. So it didn't give us the coordinate of these 2 points K and L, so we're going to write it down first. For the coordinate for K is going to be 1, 3, for L is going to be 6, 1. Okay, so that's my 2 points. I can label that as my point A, and point B, or point 1 and point 2. Okay, so it doesn't really matter. I will label that as point 1, point 2. I think that's going to be more clear for some of you. Point 1 and point 2. Now, if we're going to use the rise over run method, we can do rise over run. Now, if we look at the rise from K to L, there's change in y in the horizontal direction. Is it going up or is going down? Because it's going downward, so the rise is actually going to be a negative number. Okay, we talk about that if it's traveling up or traveling right, it's going to be positive. If it's going left or downwards, it's going to be negative. Okay, so we've talked about that in the earlier part. Okay, so because it's going down over there, so the change in units is going to be negative. So that's going to be -2. And the run is going to be positive because it's going from left to the right. So how many units to the right? It's 5 units to the right. So the gradient will be -2 on 5, or you can have it as -0.4. But if we use our method, so the gradient and slope is equals to change of y or change of x, which is y2 minus y1 over x1, x2 or x1. Okay, y2 minus y1, so that's 6. Oh, sorry, that's 1 from the second point, and take away 3 from the first point, and 6 from the second point, take away 1 from the first point. So the answer is u minus 2 over 5. Now if you're doing this method, you don't have to think as much as in the direction or the negative sign. So I find the gradient method, the change of y or change of x, is more easier, and really related back to the definition of the gradient is also talking about how many change in y in 1 unit measured of x. Okay, so that's actually corresponding with our definition over there.